Woohoo! Welcome back. Today we're going to be using the Greek alphabet to help us find sums. Yay! And I thought we would start off with a image of the Greek alphabet. Now, the Greek alphabet has existed for nearly 3,000 years. According to Wikipedia, and fingers crossed on that being good information, the Greek alphabet has existed in close to this form since 800 BCE. So that's 2000 plus a handful of years plus 800 before, so nearly 3,000 years. And this alphabet is integral to a lot of what we do in math. Already, hopefully, you're looking at this seeing things like pi. We use the Greek letter pi, lowercase. Sometimes we use capital pi. In fact, we will use that in the future. We use tau. We use theta. If you're already taking trig, you're going to know theta really well. Alpha, beta, those are starting to look a little bit like A and B. And you're going to notice like D looks like delta. And in fact, delta is a concept we use in math. So the Greek alphabet is in math. It's all over math. We love it. And so I just wanted to do a big thank you to the Greek alphabet for helping us with our math. And so I went ahead and did my best to copy the words Greek alphabet in Greek there to say thank you so much. And with the understanding that when I pronounce these letters, I learned to pronounce them from people who were not Greek. So I apologize that my pronunciation is non-Greek. It's decidedly Californian, but I will do my best. So how are we going to use the Greek alphabet? Well, we're going to go ahead and use something called sigma. Ooh, let me point it out. It's right here. It is right about where we would put our letter S, right? There's pi or P, rho, sigma, tau. So this is the S. And we're going to use this Greek letter sigma. This is a capital letter. It corresponds to capital S for sum. And we're going to use it to indicate a sum of terms. And in fact, it's not just going to be a letter, it's a whole format. So there are two ways to write this. This first way is how you're going to see it written in a lot of online situations. This is how it is formatted for Microsoft Word and in a few other settings. And you have the sigma, and down at the bottom you have I equals 1, and up at the top you've got 5. And the way we use this is the starting point, and the top is where you end. And so if I take the sum from I equals 1 to 5, a sub I, then I want a sub 1, then a sub 2, then a sub 3, then a sub 4, then a sub 5. You'll notice that I'm stepping through by 1. Sigma is specifically counting by 1. Now, the way I learned to do it, you actually format it with the sigma, which with or without those little extra bits, sometimes people just do it like that, like it looks almost like a sideways M. And the I equals 1 goes on the bottom and the 5 goes on the top. But this is very hard to format in Microsoft Word. So you're going to see this rather than these. But when people write them out by hand, they tend to look like this. Okay, so let's go ahead and practice. So if I have the sum of I from I equals 1 to 5, that says that I want to start with I equals 1, so that's 1. The pluses are the sigma. Oops. I got very excited and I connected. What? Don't look over here. What? There we go. The sigma specifically says we're adding in between. And there is another way to note if you want to multiply in between, but that's something different. So we're not going to do that here. We're going to be adding, so that's sigma. And then we're going to count from 1 to 5, and we're going to count just I. So first we've got for 1, it's 1. For 2, it's just 2. For 3, it's just 3. For 4, it's just 4. And for 5, It's 5. So we're going to take the sum. So that's 1 plus 2 plus 3 plus 4 plus 5. That's 3 plus 3 is 6 plus 4 is 10 plus 5 is 15. So that's the sum of I stepping through I equals 1 through 5. Okay, so that's nice. Let's try another one. Now you can have a different counting variable or counting letter. This one says count from k equals 1 to 5. And we're going to add them together, take k squared. So when k equals 1, we're going to do 1 squared. When k equals 2, we're going to do 2 squared. When k equals 3, we're going to do 3 squared. When k equals 4, we're going to do 4 squared. And when k equals 5, we're going to do 5 squared. And why do we know we're adding in between? Sigma means take the sum. So we're going to take the sum of all of these. So that's, let's see, 1 plus 4 plus 9 plus 16 plus 25. Oh my goodness, I'm going to need a lot of fingers for this. You might notice that you could just go ahead. 1 plus 4 is 5, plus 9 is 14, plus 16 is 30, plus 25 is 55. But keep in mind there are lots of tricks. For example, 1 plus 9 is 10, 4 plus 16 is 20. So you could do 10 plus 20 is 30, plus 25 is 55. Or let's be honest, you guys have calculators, just type it in. Boom, 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 and you get 55. So what does sigma notation tell us? It tells us what form the, it's kind of like a function here. What form the numbers are going to be taking, and we count off from 1 to 5. Okay. So, shall we try another one? Yay! Let's try another one. Excellent. Let's try another one. Now, this one's a little bit weird. Number 3 is a little bit weird. It says from j equals 1 to 5, we want to add up 5s. Okay, so for j equals 1, what's our value? 5. Okay, for j equals 2, our value is 5. You got it. For j equals 3, what is our value? 5. This is like a constant function, right? For j equals 4, oops, plus 5. And for j equals 5, 5. So it's kind of weird. It doesn't change. We just have 5 each time. So let's see, 5, 10, 15, 20, 25. That's 25. And then 4 is very much like number 3. It is, and it's sneaky because this is where I'm going to try to help you remember that mathematics and mathematicians love sneaky little tricks to see if you're paying attention. So this says sigma, right? So the sum from I equals 1 to 5 of k squared. Okay, you should be very nervous when the variable suddenly changes, right? So I've got I equals 1, k squared. Does it tell us what k is? No, it's just k squared. For I equals 2, k squared. For I equals 3, k squared. For I equals 4, k squared. For I equals 5, k squared. So it's exactly like what we got up here, except instead of for 5s, it's k squared. So 1, 2, 3, 4, 5, 5k squared. Now, I hear you all saying, wait a minute, we had a problem on the front that was like that, but it wasn't like that. Let's review. On the first page, I had from k equals 1 to 5 of k squared. So when k equals 1, we take 1 squared. So these two variables matched. Here, I've got an I here and a k there. I know, seriously, exactly. So let's do one more problem just to practice. Woohoo. Dun, dun, dun. We're actually going to do this one backwards. This is a summation, and we're going to write it using sigma notation. Now, since we aren't in a classroom together, what I recommend is you pause the video, see if you can write this down. Let's go ahead and agree. I wish you were here so we could all agree on a letter. I'm going to choose I. And you'll notice that all of a sudden we're allowed to use I, even though I is the imaginary constant. And the answer is yes. I don't know why, but somebody decided this. I think probably because they were counting using I's before I became the imaginary constant. That's a guess. Don't know for sure. Maybe someone just decided to do it this way. So I'm going to go ahead and do the summation from I equals something to something else. So something to something else of something. That's what you want to do. I know, it's very exciting. So why don't you go ahead and pause, see if you can come up with this, and then start up the video. So I'm going to say pause it now. Okay, awesome. So welcome back. I'm going to assume you all know the answer, and I don't know it quite yet. So what I'm going to do is to figure it out is I'm going to do it backwards of what we did before. I've got 2, and when I equals 2, I've got 3 squared, and when I equals 3, I've got 4 cubed. So this makes sense if I write 2 to the first. So suddenly I think my a sub n, my term, my general term would be I plus 1 to the I. What do you think? So when I equals 2, 2 plus 1 is 3 squared. When I equals 3, 3 plus 1 is 4 cubed. Okay, I think this will work. And then we need to go all the way to 100 to the 99th. So the question is, what is I there? Because so far what I know is get it? That I've got sigma from I equals 1 to I don't know of I plus 1 to the ith. And the question is, what is, oops, I wrote this too high up. Sorry about that. I got so excited about thinking, I wrote it too high. Does that ever happen to you? Okay, so now I want to know, what is I at this point? When do I stop? Do I stop at 100? Should this be 100? And the answer is, if this is I plus 1 to the ith, then the answer is I should be 99, right? 99. So I think our summation looks like this. From I equals 1, which would give us 2 to the first, all the way to 100 to the 99th is to the 99th. So I think what I want is the summation I equals 1 to 99, make it look pretty, I plus 1 to the I, and that's going to be my final answer. So is that what you got? If so, woohoo, you're awesome. If that's not what you got, you're still absolutely awesome and you're amazing, but I would encourage you to come find me, find tutors, talk to someone. Figure out what the heck is going on here and maybe ask for some practice problems. In the next couple of videos, we're going to go over some very special types of sequences and look at partial sums and do all that fun stuff. So until then, take a break, get a snack, get something to drink, rest your eyes a little bit, go out and move around, do some art, do some dance, express yourself, do chemistry or physics, whatever it is that makes you happy. And then come on back and we'll do some more math. Woohoo, and math on.